Welcome back to the next installment of the Codasip blog series discussing all things RISC-V. Hi, my name is Steve Winandy, and I am with Filip Benna, Product Marketing Engineer at Codasip. In our first installment, we took a high-level look at Codasip's RISC-V processor portfolio. In the second video, we dove deep on processor performance and what you need to consider when picking your Codasip processor. In this chapter, we will be discussing the use of an operating system with RISC-V application processors and what you need to know to successfully accomplish this. Philip, can you start by briefly explaining what an operating system is and why it might be beneficial in your application?
Sure, Steve. The operating system is an additional software that is running on the processor, which manages the user application and also the available hardware resources. Besides that, the operating system also provides common services for the applications. There are many implementations of operating systems now, and different implementations provide different services to the user. So for illustration, let's mention only some of them. Operating systems may allow several software processes, or sometimes also called threads, to run on a single processor. This is achieved through a technique called context switching, when each thread uses the hardware resources for a limited time, and then the operating system chooses another thread which will be allowed to use these resources. There is now a standard set of input-output interfaces and other peripherals which the user applications work with. These peripherals may be controlled through function and services provided also by the operating system. With several processes running on the same device, a more complex memory management is typically required. This is also a typical feature covered by the operating system. And also when the hardware needs to be controlled directly from the user application, there may be functions in the operating system libraries which will make this easier.
That makes a lot of sense. Thank you. What options do you have if you are not using an OS or using a processor that doesn't support an OS?
Okay, let's consider several operating system domains rather than specific implementations, because this will make our list of options significantly shorter. The three domains are a system not utilizing an operating system, then group of operating systems we call real-time, and the last domain, grouping all complex operating systems, which we will refer to as rich operating systems. I will now provide a little more details. The first and simplest option is not to use any operating system. The software running without any operating system layer beneath it is sometimes referred to as bare metal, because it directly controls the hardware. Then there is a large domain of operating systems, which are called real-time operating systems. Only some systems may qualify as real-time, as we will learn shortly. For sake of simplicity, we may gather all the remaining embedded operating systems in the third category and call these rich operating systems, because these typically come with a large list of features and services.
Philip, what are the benefits of utilizing an OS, and what are the most important or common services utilized by customers?
Let's have a look at the provided services domain by domain. Running no operating system obviously does not bring any operating system features to the table. There is an important feature which real-time operating systems provide and other operating systems typically don't. The response to external events is predictable. So when such event is raised, the context is switched to the responsible task in a deterministic time. The category we have called rich operating systems may come with several significant features. One of the major ones is a complex memory management. This may include techniques known also from desktop operating systems such as memory virtualization, but also memory protection through isolation of each process's memory. This is important as this prevents potentially harming processes from accessing memory of other processes. The rich operating systems also often come with a library support for a large number of commonly used peripherals.
There's so much to consider when evaluating the use of an OS. How do I choose which one meets my needs?
The selection of a convenient operating system solution largely depends on needs of your application. In case the code size of the software running on the processor is absolutely critical, then it may not make sense to use any operating system at all, as each of them will introduce additional code that needs to be stored in your memory. If your application is time critical, which means that it has to respond to some external event in a defined time frame, real-time operating system is the solution for you. Real-time operating systems come with a guaranteed maximal execution time of managed functions and also maximal response time to external events. Users of real-time operating systems have also the possibility to set up priority of tasks the operating system is managing, which will influence how resources will be assigned to different tasks by the system. Largely concurrent applications, such as implementations of various servers, are very often a good opportunity to use embedded Linux. The complex memory management it provides will handle many applications sharing the resources of the server.
Philip, it seems pretty straightforward. Do you have additional advice to offer for our listeners?
Well, I do. Nothing comes for free. As operating systems provide many services, they also have some demands. Running a bare metal software does not provide any services out of the box. However, it does not have any additional requirements on the hardware, which may be important when using very minimalistic processor. To provide a deterministic context switching, the real-time operating systems need to have a means of measuring time consumed by a task using these hardware resources. This can be obtained through a timer. Embedded Linux, which represents the third category for us, has more requirements. Apart from timer and UART, which is a common communication channel, the operating system requires additional privilege modes. These modes are used to prevent user applications from accessing hardware features which may be dangerous to other applications or the operating system itself. We have already talked about complex memory management services such as virtualization. These are typically handled by a memory management unit.
It looks like the Codasip BK7 core is best suited for utilizing an OS. Can I run FreeRTOS on BK7?
Before discussing explicitly BK7, let's have a look at the Codasip's portfolio of RISC-V processors. The portfolio consists of RISC-V processors developed by Codasip, which are BK3, BK5, and BK7, and then also SweRV cores developed by Western Digital, which are EH1, EH2, and EL2. All of the cores in the portfolio provide a timer. This makes all of them capable of running a real-time operating system such as FreeRTOS. Only BK7, however, provides the additional capabilities to run embedded Linux. This is why this core is the first Linux-capable core developed by Codasip. Although it is technically possible to run real-time operating system on BK7, you have to understand that the additional hardware needed to run embedded Linux will still be in the core, and therefore may be enlarging the area of your chip unnecessarily. So what are the most important things to remember from this video blog? Operating systems bring in many useful features, and by using operating system, you may reduce the complexity of code you have to implement yourself. There are many types of operating systems which were designed for different use cases, so there is no universal choice among existing operating systems. Operating systems also have their own hardware requirements, so you should not use more complex solution than you need so that you don't pay too big hardware price.
Thank you, Philip. You have provided a lot of great information on various things you need to consider when selecting a core and corresponding OS. This concludes our session on using an OS with our processor system. Please join us for the next post in the series where we take a deeper dive into the new BK7 core, its advantages, and how that helps you create an embedded system you require. Thank you for watching, and we look forward to seeing you next time.